Thanks for trying to set up your notes. One sec. The title, well, this comes from 3 sections in your book, 6.3 through 6.4. Properties of, what do these 2 vertical lines mean? Parallel. And what does this upside down T with a square in the corner mean? Perpendicular lines. Central question, there are 2. How do you prove 2 lines are parallel? And how can you prove 2 angles are congruent given that you have 2 parallel lines cut by a transversal? Okay, question?
Do you have a rectangle you want to take?
You can. Uh, 6.3 through 6.5. Okay, I'm assuming all of you are using lined paper. Would you skip down about 5 lines and skip down about 5 lines and take your ruler and make one of those blue lines on your paper really, really dark and straight all the way across. Skip down like 5 lines underneath where you wrote. And draw a solid straight line all the way across. Okay, next what I want you to do is I want you to take your triangle you cut out and colored and line it up so that it is even. It's sitting right on top of that line. I need to scoop mine down a little bit. And then I want you to trace it and color in the corners just like your triangle is already colored in. Guys, the coloring is important. So if this is how my triangle sat on my picture, I would make sure my bottom left, I definitely have to color red. And my top corner, I definitely have to color blue. And my bottom, I definitely have to color green. There's a reason for the coloring, so make sure you're coloring the corresponding angles with the color that matches your triangle. And it should be sitting flat on your line, actually. So you might need to move your line up. Have it sit flat on your line. You trace it, lift up your little stencil piece, go all the way to the left. Trace it, lift up your stencil piece, and color the angles. It's important that we keep these 3 colors consistent. So as we do this, don't be changing your colors. Okay. Now what I'm going to do is I'm going to lift up my triangle. Oops, I'm going to copy this really quick. Where's the paste button? Oh, paste? Aha. What I'm going to do is I'm going to lift up my triangle, and I'm going to make a duplicate, but the corner needs to touch. It should be on that line you drew, and it should be right next door, touching corner to corner. I want you to trace it again, and color the angles the same way you did the first one. Yep, that's fine. If it goes off the edge of the paper, that's all right. Trace what you can. And color the angles the same way you did the first one. Same colors, don't change the colors. Yep. That has to touch the corner. Touching the corner is important. Corner to corner, angle to angle, they should be touching. And then continue this process until you're off the page. Some of you have a bigger triangle, so you're already off the page. Others need to keep going. Okay, once you're off the page, we're going to make another copy, but we're going to rotate. Now, if my triangle was originally here, I'm going to do a 180-degree rotation and slide it into that gap. It's important how you rotate. Basically, flip your triangle upside down, 180-degree rotation, and slide it into that gap, and color the corners the exact way that your triangle is colored. These colors are important, so please be very careful which color you're using on each angle. And continue to the next gap as well. Fill in all the gaps, all the way off your page. Does anyone know what this is called that we are making? Such as the T? Triangles? Tessellation. A tessellation. So you have a bunch of upward triangles and a bunch of downward triangles. And you're filling in the angle with the exact color that represents the angle on your cutout triangle. Okay, when you are done and you have the whole top row, we're going to create a second row. If you can put your triangle back on that original spot, the very first spot. And again, we want to rotate it 180 degrees, and it will slip right underneath there. So your angle colors don't match up. So I'm going to rotate 180 degrees about the midpoint of the bottom, the base. So that, notice, my red didn't match with the red. I have a red and green on both ends. Yeah? That's fine. Or you can do it underneath. You can go down here. So make a second row. So now I have, mine's kind of like an upside down triangle, and I can repeat this upside down triangle a handful of times. Copy, paste. A tessellation is a repeated image that fits within itself, like a puzzle. We're on a short day today, but maybe next time, if I remember, I can show you some really cool tessellation pictures. What?
And then I totally forgot to bring my notebook that has them, so can I bring it next time?
The 380?
The
Yeah, you're going to have to correct it yourself, though. Once you have the second row, mine's only halfway done. I need to fill in all of these gaps with another triangle. So I'm going to rotate it up and slide it into the gap. And when you're ready, do a third row. And if it goes off the bottom of your page, that's fine. But get as much of a third row as you can do. Some people are able to do a third row. Some people are drooping below the page, and that's fine. Do a third row. I am cheating. Oops, that is the wrong one. I guess I can just rotate it. Aha. Okay, I think once you get 3 rows, it'll have enough to be able to see and prove these theorems. That looks pretty cool, don't you think? No? I think it looks cool. Okay, about 1 more minute. Okay, I want you to find a color that you haven't used yet that would make a statement on your paper. Like if you've been using a lot of light, you use a light pencil, maybe a dark color would be best for you. If you've been using a lot of dark, like you have really dark lines, you might want to consider like a yellow, something that would pop off your paper. Mine are dark, so I'm going to go with a yellow. And what I want is, the reason we did three rows is because I want the 2 interior parallel lines. The 2 interior, whoops, too skinny. The 2 interior parallel lines, I want you to highlight them. I feel like this is still too light. And it needs, or yeah, if you have a highlighter, go with that. I want these 2 lines to be distinct and have them jump off your paper so you can actually see them. Ah, there we go. And I need it to be the interior parallel lines, not the exterior parallel lines. Then I need you to take that same color and highlight one of the transversals. What's a transversal? A line that cuts through, in our case, the 2 parallel lines. So I would choose one of the ones in the middle, and you only need one. Right there. Make sure it's in the middle. Now last time we talked about a lot of different angle relationships, but we didn't talk about them with respect to parallel lines. There's a special little thing that happens if you have 2 parallel lines cut by a transversal. A special relationship happens. So we've color-coded for a reason. Would you agree that all of my green angles on there are congruent to all of the green angles? Would you agree that all the blue angles on there are congruent to all the blue angles? Because it's the same triangle, right? So we have like the reflexive property, anything that's congruent to itself, because we use the exact same triangle. So, looking at our diagram, we should be able to conclude some theorems. Okay, if we have given parallel lines, that's important. Given parallel lines, it has to be parallel for this to work. Given parallel lines, cut by a transversal, some special properties happen. Look at this top right exterior, and this inside right exterior. What are those called when they are on the same part of the intersection? Do you have your notes from last time? I gave you, at the very end of your notes last time, I gave you lots of, I think there are 5 different angle relationships. What's it called if they are the same angle of the same part of the intersection? It's a C word. It's one of the C ones. Corresponding. So this top right corresponds to this top right of the intersection. And the intersection being right here and right here. Look at their colors. What color are they? They're both red, so that means corresponding angles, when parallel lines cut by a transversal, corresponding angles have to be congruent. Let's just make sure this is true on other parts. What about, say, the bottom right of that intersection and the bottom right of this intersection? Do they both have blue and green? Yes. So, all of these have the same given. Given parallel lines cut by a transversal. Given parallel lines cut by a transversal, corresponding angles, CA, corresponding angles are congruent. So if we had some values in those angles, we knew one was 45, the other one would also have to be 45. We can solve for a missing angle or the x value inside that angle, knowing that both of them are congruent. Oops. What am I doing? Delete. Delete. Okay, corresponding angles are congruent. Let's look at a different type of angle. We have, remember with our parallel lines, we have like this tube with water spilling out. So we have an inside of the tube and an outside of the tube. This angle is inside the tube. And this angle is also inside the tube, meaning inside the parallel lines. But one is on the top left, one is on the bottom right. What did we call those on our notes last time? Alternate interior angles, AIA. Alternate interior angles are, guesses? I have a red angle and a red angle, so they are congruent. If I did the other alternate interior angles, top right, bottom left, alternate meaning opposite, are those also congruent? We have a blue-green and a blue-green. So alternate interior angles are congruent. AIA. Given parallel lines cut by a transversal, alternate interior angles are congruent. Given parallel lines cut by a transversal, alternate interior angles are congruent. What were some of the others on our list? There's 5 of them. We've just done 2. What's another one on our list? There's another word with the exterior, though. Alternate exterior. So this is our tube again. Exterior. If, say, I did the top left of the exterior, what would the alternate be? Bottom right. What do you think about those 2 angles? Are they congruent? Blue-green, blue-green. Yep. So EIA. Oops, I spelled that wrong. Alternate exterior. AEA. That's what I want. Alternate exterior angles are congruent. Given that we have 2 parallel lines cut by a transversal. That's what the given has to be every time. Given 2 parallel lines cut by a transversal, alternate exterior angles are congruent. I know there's CIA. I want to do CIA last. What's the other one I'm missing? That's CIA. Wasn't there a 5th one? Maybe it's just vertical angles. Let's look at vertical angles. Oh, I gotta delete these now. Delete. Delete. Okay, do we have vertical angles in here? So, like right there, vertical angles with Blue-green. So this is another proof. Well, I just told you last time, and now we've just proved it. What do we know about vertical angles? Vertical angles are congruent. And they don't even have to be parallel lines. Vertical angles are congruent. I'm going to just do the congruent symbol. The equal with the little squiggly. Okay, and the last one we haven't done yet is CIA. What does CIA stand for? Consecutive interior angles. Consecutive interior angles. Let's look at our diagram. Consecutive interior angles means they can be across the street neighbors on the inside, or they can be right next door neighbors on the inside. Let me erase that. Okay, here's my parallel lines, right? These are next door neighbors. Look at those colors. One's blue-green neighbor, the other one's red neighbor. Are consecutive interior angles congruent? What do consecutive interior angles create? They're not congruent. It's not a red and a red. We have blue, green, and red. What? What is it? Supplementary. Let's make sure it works across the street. Across the street, do we get blue, green, and red? Neighbors over here, blue, green, and red. And one more across the street, blue, green, and red. Consecutive interior angles are not, they could be congruent if they happen to be all 90 degrees, but they are supplementary. So that's the tricky one. Are supplementary, meaning they're a linear pair that adds up to 180 degrees. This is all given parallel lines cut by a transversal. The reverse is given corresponding angles with a transversal. Therefore, the lines are parallel. Given alternate interior angles cut by a transversal are congruent, the lines are parallel. So you can go both ways. Your homework tonight, unfortunately, I thought I was putting on white paper, but unfortunately it came out yellow, and our packet last time was also yellow. So sorry about that. You can send one runner up to return supplies into the baskets that are up there. Make sure the crayons are zipped up. Make sure your paper scraps make it into the garbage or the recycling bin. Your homework tonight is using these properties, knowing that they are congruent, finding missing angles, and proving that lines are parallel. Make sure you get a yellow packet before you leave. And parent-teacher conference is tonight, 4:30 to 7:30. Extra credit if your parents come. So send one person with your rulers, your crayons, and your scissors if you could. So there are just 4 of you here?